Let's talk about square roots. In this video, you will learn how to get the square root of any number manually. For example, what is the square root of 425? Now most of you will go press, voila. Now I will be showing you two methods, the nitty-gritty method, and the other one, pre-calculus, the easier way. Now let me direct you to the whiteboard behind me. Now, in order for you to fully understand the concept of square root, you also must have a basic idea of what exponents are, particularly those of exponent 2. Exponential, simply put, is the repeated multiplication of a number by itself. So for example, 2 raised to 2 is 4, 3 raised to 2 is 9, 4 raised to 2 is 16. See, you double the number each time. Now math is all about control. It is like driving a car forward and knowing how to go reverse. Square root literally does that. So the square root of 4 is 2, square root of 9 is 3, square root of 16 is 4. It's just the opposite. Now, before we proceed, I may need you to remember these pointers. There are 5 of them, and this is one of them. Square roots has no fixed divisor and no fixed multiplier going down. So for example, in a normal division process, we have a fixed divisor here on its left. And so what we do here is we divide 12 by a fixed divisor 5, and going down we have a multiplier also, so until we arrive here at 25. On the contrary, square roots has no fixed divisors. It has multiple variable divisors, and it keeps changing. Now the key here is the number 20. There's something magical about the number 20 with regards to square roots. Next, we go to the next pointer. Going to the next pointer, knowing where to demarcate the radicand. Now partitioning is a very important skill for us to learn. It is very crucial to find the correct answer. Now some people will partition here, thinking that the quotient is 30, because 30 times 30 is 900. And that will give you an incorrect answer. Some people may demarcate here, thinking that the quotient is 17. But 17 times 17 is 289, a very convenient subtrend for the 325. Now, what is the best way to deal with all three cases? So we have 9025, 425, and 5781. All you had to do is demarcate here, and more likely or not, this whole thing is the main root derivable whole number. Same thing here and here. Let's head on to the next one. Now we go to the basics. Now the idea is to find the nearest perfect root as the quotient. And the nearest perfect root for 78 is 64. That's why we write 8 up here, because 8 times 8 is 64, giving you a difference of 14. Notice the padded pairs of zeros after it. That's because 78 is not a perfect square. If it had been a perfect square like 49, then we will not be expecting any trailing decimals after 8. And non-perfect roots, non-perfect roots, non-perfect roots, 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 non-perfect roots. And now we move on to pointer number 3. Now this is the most important of them all, because this is where you will find your divisor and your multiplier. And since it is always changing, you may find some difficulty in finding them. So please memorize them. Pointer number 3. The new dividend's divisor will be the current entire quotient found times the number 20. This number will be called 20's child, but its multiplier will be the product of the 20's child plus the newly found single digit. The multiplier will again be multiplied with the same newly found single digit, and then the pattern repeats. Moving on to rule number 4. Every time the main root derivable whole number experiences a perfect root, the next two partitioned pair of digits will have an automatic 0 as its quotient. Now 64 is a perfect root. That's why we write 8. Now it says here the next two partitioned pair of digits will have an automatic 0 as its quotient. So we write 0. And lastly, always check your answer by multiplying the number to itself. So let's have some exercises. Now let us find the square root of 78. Now the nearest perfect root of 78 is 64. That's why we write 8. Because 8 times 8 is 64. Going down gives 14. Now, are we expecting trailing zeros? Yes, we are. So we add zeros, a pair of zeros. Now, this is a situation where you get lost because there's no fixed divisor, beside the fact that 1400 is getting lonely. Here's where number 20 comes to the rescue, so we write 20.